For centuries, humans have looked up at the stars and wondered, does the universe ever end? If you kept traveling in one direction forever, would you reach a wall, an edge, or fall off into nothingness? It sounds like a simple question, but it's one of the hardest in all of physics. Because to answer it, we first have to understand what space actually is and what it means for something to have an edge. Let's start with what we know. The observable universe, the part we can actually see, is about 93 billion light-years across. That means light from the most distant galaxies we can detect has been traveling for almost 14 billion years since the Big Bang. But that doesn't mean the universe ends there. It only means that light beyond that distance hasn't had enough time to reach us yet. So the edge of the observable universe isn't a wall, it's a limit set by time itself. Beyond that, space probably continues. We just can't see it. Now, scientists think the universe is expanding. This means galaxies are moving away from each other as space itself stretches. But here's where things get strange. Space isn't expanding into anything. It's not like an explosion with debris flying into empty space. It's more like the surface of a balloon inflating. When the balloon grows, every point on the surface moves away from every other point, but there's no center on the surface and no edge. If you were a two-dimensional creature living on that balloon, you could travel in a straight line forever and never find an end. You just circle back to where you started. That's one way cosmologists describe the universe: finite but unbounded. So, the universe may not have an edge in the traditional sense. You can't reach the end of space because space curves back on itself. But how do we know whether that's true? Scientists study something called cosmic curvature, the way space bends under the influence of gravity and energy. Einstein's theory of general relativity tells us that massive objects can warp spacetime. The entire universe might do the same thing on a grand scale. If the universe has positive curvature, it's like a sphere, closed and finite, but with no edge. If it has negative curvature, it's like a saddle, infinite, but still curved. And if the curvature is flat, it could stretch out forever in all directions. The best measurements we have from satellites like Planck suggest that the universe is almost perfectly flat, meaning that, at least as far as we can tell, it could go on infinitely. But almost flat isn't the same as definitely infinite. Even a huge sphere can look flat if you're standing on a small part of it. To visualize it, think of standing on Earth. It looks flat to you, but from far away, you can see it's round. The same might be true for the cosmos. We only see a small patch, so it appears flat. But if we could somehow zoom out far enough, we might realize it loops back on itself. Then there's another complication: the expansion of the universe. Because the universe is expanding faster and faster due to dark energy, most galaxies are moving away so quickly that their light will never reach us. Even if the universe is infinite, we'll only ever see a tiny fraction of it. In the far future, distant galaxies will drift so far away that our night sky will go completely dark, not because the universe ended, but because its light can no longer catch up to us. So, does the universe have a border, a limit, or an edge? Based on everything we know, the answer is no, not in the way we imagine it. Space doesn't stop. It doesn't have walls or boundaries. Instead, it's either infinite or curves in on itself in higher dimensions that we can't perceive. But there's still an important twist. The observable universe does have a kind of edge, the cosmic horizon. It's the boundary beyond which we can't see, not because space ends, but because time does. Light from beyond that horizon hasn't had enough time to reach us since the Big Bang. Every year that passes, the horizon expands a little further, revealing new parts of the universe. But at the same time, other galaxies are moving out of view faster than light can reach us. It's like standing on a cosmic island surrounded by an ocean that keeps growing faster than you can swim. There are also deeper, mind-bending possibilities. Some theories suggest that our universe might just be one of many in a vast multiverse. In that case, what we call the edge could simply be a connection to another region of reality, a different universe with its own physical laws. Others propose that our universe might be part of a higher dimensional space, a kind of cosmic bubble floating among countless others. If that's true, our universe might technically have an edge, but it's one we can never reach, because it exists beyond our dimensions of space and time. There's even the holographic principle, which suggests that everything we experience as three-dimensional might actually be information encoded on a two-dimensional surface at the edge of the universe. In that case, the edge isn't a wall, but a boundary of information, the place where the universe stores everything that happens inside it. So whether the universe is infinite, looping, or part of something bigger, the edge may not be a place we can ever visit or see. It might just be a limit of our perception, a horizon drawn by the speed of light and the flow of time. In the end, the question, does the universe have an edge, might tell us more about our minds than about space itself. Because as humans, we're used to things having boundaries, a start, a middle, and an end. But the universe may not work that way. It may be endless, boundless, and self-contained, a reality with no outside to step into. So maybe the better question isn't where the edge is, but why there has to be one at all. Don't forget to like, share, and subscribe to WiseUse, because curiosity doesn't end, it only expands, just like the universe.